This is part 9 of the series Right Triangles and Trigonometry, and before I moved on to a different example, I wanted to rework this problem, but in this time use the other acute angle. Now, if we work this, we know that since this angle is 34, then this angle is going to be 56. So this angle is 56 degrees. Now let's use this angle to find y. Starting here, we would have some old horse. Well, that doesn't work because we don't have any length for this side. Then we have to go back and go to the next version. So some old horse caught a horse. In this case, from this angle, it's cosine. So we would have cosine of 56 equals caught a horse. Caught a horse. And in the same way we solved for this one, we're going to solve for this one. So we multiply both sides by y, multiply by y. Y cosine 56 equals 7. These canceled out. Divide by cosine 56. Y equals 7 divided by cosine 56. Again, remember, sine, cosine, and tangent are just numbers. They're just ratios. These functions generate a ratio. So we put that into our calculator, and what we come up with is 7 divided by cosine 56. And notice we get the exact same value with the two different angles. So it didn't matter which one you used. The issue was that you just had to use the right set of sides. So caught a horse. And again, this becomes approximately equal to 12.5. All right, let's move on to another example. In this example, we have a slightly different arrangement. And we have one angle here. We're looking for side JL, leg JL, and we're given leg 9. So let's continue on. We know that we have to start at the angle, and we run through our limerick. Some old opposite H horse. Can't use it because we don't have the hypotenuse. Caught a adjacent horse. Can't use it, don't have the hypotenuse. Taking oats opposite away adjacent. That's the one because it has all three of the values that we know in this triangle. Taking oats away. So the ratio, our target ratio, is going to be tangent. So we say tangent of 56, the angle always goes in as the input to the function, equals taking oats away. Oats away. Again, we're going to multiply both sides by x. In our examples up to this point, all of our variables have been in the denominator. That's not always going to be the case. You just have to exercise basic algebraic practices to solve for your variable, no matter what the circumstance. So we multiply both sides by x in this case. Multiply by x. We have x times the tangent of 56 equals 9. And now this is just a number, so we're going to divide both sides by this number because we have to isolate the x. X equals 9 divided by the tangent of 56. Again, we bring up our calculator, and we have 9 divided by tangent 56, and it gives us 6.1 approximately. So it's approximately 6.1. Again, if we wanted to use the other angle, we would simply have to subtract this from 90, which is 34, and we do the same exact thing, only with this angle. Some old horse, no, doesn't work, don't have the hypotenuse, caught a horse taking oats away. Tangent again. So tangent of 34 equals taking oats away. In this case now, we have the x on top, oats away. Now we're just going to multiply by the 9. So multiply by 9, multiply by 9. So x equals 9 times the tangent of 34 degrees. So let's go ahead and put that in our calculator. 9 tangent 34. And you'll notice it gives us the exact same value, 6.1. So this is approximately equal to 6.1. All right, let's do one more example. In this example, we're given angle P is 14 degrees, leg QP is 6, and we're looking for the hypotenuse in this case. So as we've been doing in the past, we start at the angle, run through our limerick. Sum, old, opposite, horse. Nope, can't use it because we don't have QR. Caught a horse. Caught adjacent over hypotenuse. That's the one because it has all three of the values we're looking for. So our target ratio is cosine. Cosine of 14 equals caught a horse. 6 over x. Multiply both sides by x. Then we have x cosine 14 equals 6. Divide by cosine 14. X equals 6 over cosine 14. Again, we go to our calculator. 6 divided by cosine 14. And we get 6.2 approximately. Approximately 6.2. Again, if we want to work with angle R, we just need to subtract that from 90, which is 76, and we run through the limerick again. So we have sum, old, horse, and it's sine in this case, sum, old, horse. So the sine of 76, because we started at this angle, equals old horse. Multiply both sides by x. X sine 76 equals 6. Divide by sine 76. X equals 6 over sine 76. And that's going to be approximately equal to 6 divided by sine 76. The exact same value, 6.2. Now we're going to look at some examples that aren't quite so straightforward, and we're going to be looking for the angles rather than the sides. So let's look at that version of trigonometric functions. In this problem, we're being asked to solve the right triangle. Now what that means is that we have to find all the missing angles and all the missing sides. In this case, the only angle we have is the right angle. We're missing angle B and angle C, and we need to find side BA. Now, finding the side is relatively straightforward because we're just going to use Pythagorean theorem. Finding the angles, on the other hand, is going to require a different level of trigonometric function. So let's go ahead first and get this side out of the way and solve for that. By the Pythagorean theorem, we have BA squared plus 7 squared equals 13 squared. BA squared equals 13 squared minus 7 squared BA equals the square root of 13 squared minus 7 squared. That comes out to square root 13 squared minus 7 squared. And that's 10.95. We could say 11 if we're rounding up to the nearest whole number. So that's approximately equal to 11. Now, I'm not going to spend the energy to worry about exact values for this particular problem. It's not really relevant to what we're trying to learn. So this is approximately equal to 11 over here. Now, let's switch our attention to the angles. In order to find these angles, we set up the exact same relationship that we would if we actually had the value sitting here. We're looking for the angle, remember. So let's start with C. I'm not going to use this side because this is an approximation. Sine, cosine, and tangent generate approximations, and if I use an approximation to find an approximation, I'm going to compound my error. So I'm going to use my exact values here whenever possible and avoid using an approximated number just because I don't want to induce additional error. So some old horse, no, don't want to use it because I don't want to use the 11. Caught a horse, that's the one. I'm going to use cosine. Cosine of C equals adjacent over hypotenuse. Caught a horse. Adjacent over hypotenuse. Now, we have a problem. We need to solve for angle C. Just like we did in basic algebra, when we're adding a number, we do the inverse. We subtract. When we multiply two numbers, we have to divide. So if we had 2x equals 3, we would divide because that's the inverse operation of multiplication. Just in this case, we have inverse functions as well. The inverse function of cosine is called arc cosine. It's spelled ARC, cosine. I usually just write it like this, cosine -1, simply because it is easier to write. Cosine -1. Arc cosine, both the same thing. And just as in multiplication undoes division and division undoes multiplication, arc cosine undoes cosine. Now there are some caveats there, but we're not going to worry about those at this point. We'll worry about those at a future date. But what I do to one side, I have to do to the other. So I'm taking the arc cos of this side as well. The arc cos of cos is just the value. So think of this in terms of square root as well. If we take the square root of something squared, the square root undoes the square and we have that thing. Well, arc cosine undoes cosine, so we just have C left. Equals arc cos of 7 over 13. Now you'll notice that the arc function takes a ratio as opposed to the regular function takes in an angle. And the arc functions generate an angle. So now we just turn to our calculator and we say second cosine here. Notice we're going to use this function up here, cosine -1, which is arc cosine of 7 over 13. And that gives us an angle measure now of 57.4 degrees. So this is approximately equal to 57.4 degrees. So notice again, the arc functions take in a ratio and generate an angle, whereas sine, cosine, and tangent take in an angle and generate a ratio. So we're going to continue this example in the next session, and we'll see how this applies in other situations as well.